Assalamualaikum and good day everyone. Today we will continue our chapter 5, which is 5.3, tree traversal. At the end of the class, you should be able to determine pre-order traversal, in-order traversal and post-order traversal of an ordered rotated tree, and also determine the infix, prefix and postfix form of an expression. Okay, let's see for the tree traversal. Tree traversal is a procedure for systematically visiting each vertex of an ordered rotated tree to access data. Ordered rotated tree are often used to restore data or info. If tree is labeled by universal address system, you can totally order the vertices using lexicographic ordering. So this is the example for using lexicographic ordering. There are three different tree traversal algorithm, which are pre-order, in-order, post-order traversal. So let's see for the pre-order traversal. Let T be an ordered rotated tree with root R. If T consists only R, then R is the pre-order traversal of T. If T1, T2 until Tn are subtree at R from left to right in T, then the pre-order traversal begin with by visiting R. Continue by traversing T1, then T2 and so on until Tn is traversed in pre-order. So the tip for the pre-order traversal is we need to visit the root, then we visit the subtree from left to right. So the first one we need to visit the root and then we visit the subtree from left to right. So let's see for the example of the pre-order traversal. Okay, we have the tree here with the root A here, and we see that the tip for the pre-order traversal is to visit from root and then visit subtree left to right. So we have root here is A, so from left to right we have B, C, D. So the first iteration is A, B, C, D. So we bring along all the children here. And for the second iteration, we see at the first iteration, we see that we have the root, we have the subgraph at the B with the rooted at B, and we have the subgraph with the root at D. Okay, so we know that the B as the root and also D as the root, so we need to visit root and then visit subtree left to right. So we have root B here, and then we read from left to right, we have E, F here. So we have for B, we have B, E, F. So for the second iteration, we have the B, E, F here. So for the D, we have D, G, H, I. So we have D, G, H, I. So we bring along all the children. So we repeat the step until we get the final answer. There are no children. So we get the answer for the pre-order traversal is A, B, E, J, K, N, O, P, F, C, D, G, L, M, H, I. So this is the pre-order of traversal of T. Alright, let's see for the in-order traversal. Alright, for the in-order traversal, let T be an ordered rotated tree with root R. Okay, we just see the tip for the in-order traversal. The tip for in-order traversal is firstly we need to visit leftmost subtree, and then we visit the root, and then we visit other subtree from left to right. So the first step is we need to visit the leftmost subtree, and then we visit the root, and then after that baru kita visit other tree left to right. Alright. So let's see the example. So we have the same graph, the same tree here with the root A. So we know that in this tree we have the A as a root and B is the leftmost subtree. So for the first iteration we have the B as the most left subtree, and then we visit the root as the A, and then we visit other subtree left to right. So we have the B, A, C, and D. So we have here B, A, C, D. Okay. So for the second iteration, we take B as a root, so E as the leftmost subtree. So we have the in order traversal as the for the second iteration is the EBF. Alright, so we put here is EBF. So for the D, we have the GDHI. So we have here GDHI for the second iteration. So the other is just copy and paste. Alright, for the next iteration, we continue the same step until we get all the in order traversal of T. So we have here the in order traversal of T is JENKOPBFACLGMDHI. So this is the final answer for the in order traversal of T. Alright, let's see for the post order traversal. For the post order traversal, we need to visit the subtree left to right, and then after that baru we visit root. Alright. So firstly we need to visit subtree left to right, and then after that baru visit root. So this is contradict to the pre-order traversal. Alright. So let's see the example. So we know that we have root A here. So root A here, and the subtree left to right is BCD. So we have the B, for the first iteration, we have the BCD and A as the root at the last of the order. Okay. So for the second iteration, we have B as the root, so we need to read from left to right. So we have E, F, and B. So we write down as the E, F, and B. So for the D is with G, H, I, D. So we have here is G, H, I, D for the second iteration. Okay, we continue the step until we get the post order traversal of T. Okay, so this is the final answer for the post order traversal of T, which is JNOPKEFBCLMGHID Okay. Okay, this is an exercise. We have 6 questions for you to test your limit of understanding in the pre-order, in order, and the post order traversal. Let's see for the infix, prefix, and postfix notation. Okay, before we see the infix, prefix, postfix, we need to know how to represent expression by the rooted tree. We can represent complicated expression, proposition set, and arithmetic using ordered rooted tree. Let's see the example. A binary tree representing the expression bracket x plus y power of 2 plus x minus 4 divided by 3. Alright. In this expression, we can see we can have two expression here. This first expression and the second expression. And this expression is connecting with the operation plus. So this plus is we use as the root of our binary tree. And for the first expression is we put on the left side of our binary tree, and for the second iteration we put on the right side of our binary tree. Alright, let's see how we want to draw the binary tree. So we have plus as a root. So for the first expression is for the left side of our tree. So we see here we do not choose in the bracket, we choose outside the bracket first. So we see here we have the bracket x plus y power of 2. So the first, since we do not choose in the bracket first, so we choose power of 2, the operation power here. So the operation power here, so we put at the left side of the tree. So we have power here, and we see that we have if we choose the power, we have 2 at the right side, and the x plus y at the left side. So at the right side, so that means we need to put at the right side of the graph, and the left side is we need to put as the left side of the graph. So let's see here, we have 2 here, 2 here we put on the right side, and for the left side we put on the, we see that from the left side we have the x plus y, so we have the operation plus here, so we need to choose for the operation first. So we at the left side we have the plus, so we have the plus here, and then after that we write down the x and y. Okay, so let's see for the second iteration expression. For the second expression also we do the same. We choose the divide first, operation divide first, and then we have divide here. So we see that we have 3 and x minus 4, so 3 at the right side, and the x minus 4, we see we have the operation minus here, so we need to put the operation first, so minus, and then after that baru we put x and 4, right? Okay, that's all how to represent the by the rooted 3, okay, from the complicated expression. Okay, let's see. So let's continue for our infix, prefix and the postfix notation. For the infix, prefix, postfix, the tip is you need to understanding how to do the in order, pre-order and the post-order traversal. If you already understanding in order, pre-order and the post-order, so you can easily understanding how to do the infix, prefix and the postfix notation. Okay, let's see for the infix form. We obtain the infix form of an expression when we traverse it rooted 3 in order. So we know that in order traversal, we visit leftmost sub-tree, visit root, and then visit other sub-tree to the right. So we have the infix form for, so this is the example, the infix form for the expression x plus y power of 2 plus x minus 4 divided by 3. So we already learn how to draw the graph in our previous, so this is the graph. So how we want to know the infix form is we use the in order traversal. So we visit the leftmost, and then visit root, and then visit sub-tree left to the right. So we have the, we already learned how to the in order, so you just try it out. I believe you can do the in order by your own. Okay, so this is the final answer. X plus y power of 2 plus x minus 4 divided by 3 for the infix form. Alright, it's same for the prefix form. For the prefix form, we obtain of an expression when we traverse it rooted 3 in pre-order. So we know that the pre-order traversal, we visit root, and then we visit sub-tree left to right. So we just use this tip using these 3. So the answer we get is, for the prefix form is plus power plus x y 2 divided by negative x for 3. Since I already show you how to find the pre-order traversal, so I believe that you can do by your own to find out the prefix form in the pre-order traversal. Alright, let's see for the postfix notation. We obtain the postfix form of an expression when we traverse it rooted 3 in the post order. Okay, for the post order traversal, we know that we visit sub-tree left to right, and then visit root. So we get the final answer, xy plus 2 power of x 4 minus 3 divide by divide and plus. Alright, that's all for the infix, prefix and postfix. You need to understand the in order, pre-order and post-order, so you can do well in the infix, prefix and the postfix notation. Alright, let's move to the evaluating prefix expression. Okay, for the evaluating prefix expression, we're working right to left and performing operation using the operand on the right. So this is the example. The value of the prefix expression is here. We give you the expression. So for the first, you need to see from right to the left. Okay. So our first operation here is from right to the left. We see that our first operation here is power. So we get 2 power of 3 is equal to 8. Right? So we put 8 here at the second, and then we see for the second operation here is divide. So 8, since we know that left to the right, so 8 divide by 4. So we get 2. So we put here 2, and then we see here the operation on the right is multiply. So 2 multiply by 3. So we get 6 here. So we see that the right of operation is minus. So 6 minus 5, we get 1. And then 1 plus 2, we get 3. So the value of the prefix expression is 3. So that's all for the prefix expression. So for the evaluating postfix expression is we need to working from left to right. So from left to right, and the performing operation is the operator on the left. So we see here, we have left to right. We see the most left operation is multiply. So we need to consider multiply here. So multiply 2 plus 3, 2 multiplied by 3. So we equal to 6. So next we see that the most left operation here is minus. So we see 7 minus 6 is equal to 1. So we get 1 here. So we see the power 1 power of 4 is equal to 1. So you see here the most left operation here is the divided. So we have the 9 divided by 3. So equal to 3. So 1 plus 3 is equal to 4. So the value of the postfix expression is 4. That's all. This is just an easy mathematics. Alright, let's see. This is your exercise. So you can do by your own. And that's all for today. This is just an easy subtopic. So that's all for today. Thank you.